Okay, ladies and gentlemen, I bumped into one of your classmates today, and she told me that she needed help with some special products. Okay, products. Um, Sorry about that. But anyways, let's get started here. Okay, warning: you're gonna have to think quick and pause the video on several occasions. All right. So here was one of the problems that was shown to me, and before I address this one, I wanted to do a quick lesson on some special products. Okay, so first of all, look at the three expressions I have circled in green there. Okay, you should recognize all of these as difference of two squares. Okay, and what we mean by that is, notice how x squared is really x times x, right? 16x squared is 4x times 4x, correct? They're perfect squares. Likewise, the 9 is 3 times 3, isn't it? And the 81 is 9 times 9. Well, the way the difference of two squareds works is really simple. If I just take x plus 3 times x minus 3, the result is what I started out with there. So this over here, guys, is the factored form of x squared minus 9. Likewise, hopefully you can figure it out already, I'm going to make this a 4x plus 9 and a 4x minus 9. And what I have there, again, is the factored form of what I started there. So what I'd like you guys to do is, can you factor these two differences of perfect squares for me? Please pause the video and give it a shot. Okay, hopefully you paused the video, but let's see how we would approach this one. 25x squared is a perfect square, right? What is that? It's, of course, 5x times 5x, right? 5x times 5x. And isn't the 4 simply 2 times 2? And if you made 1 plus and 1 minus, you have the factored form of this difference of two squareds. Okay? Now, I do have other videos on difference of two squares that you ought to check out on Novi Math Stars on YouTube. Okay? If you want a more in-depth discussion of difference of two squares. But anyways, that's one type of special product. Okay? The other type is what we see below, which I'm going to circle now in purple. See those three expressions circled in purple? Okay? Now let me show you. I'm going to actually multiply them using the pattern. It's not magic, guys. It's an actual pattern. Okay? And so what would be this first one, you see, would be, I know the 2x is going to be squared, which is 4x squared. I know the 3 is going to be squared, and I'm going to get 9. Now notice I left a space in the middle there, because part of the pattern is, I know I'm also going to do 2x times 3, 6x, but it's going to be doubled, 12x. And I, using the pattern, guys, just multiplied that. So my final result is 4x squared plus 12x plus 9. Okay? Now let me do it a little bit faster. I know the 4x is what when I square it? 16x squared. Again, that squared is what is doing the trick there. I know the minus 7 when I square it is 49. And finally, when I times them together, I get minus 28x, but it's going to be doubled. So what's 28 doubled? Well, that's a minus 56x. And so that's how it's done. So what I'd like you to do, guys, is could you please try the last expression now using that same pattern? Please pause the video right now. Okay, hopefully what you got was 25x squared, because after all that was 5x squared, right? 5x times 5x. Hopefully you got a plus 1 at the end, because 1 times 1, or 1 squared is 1, and timesing it together, you should have gotten 5x, but it's going to double. That's the pattern, guys. You're going to get 10x. So hopefully you understand that special product. Okay, now that you hopefully understand that, guys, pause the video, by the way, if you need to right now. But now that you understand that, hopefully, let's get to some graphing. For example, look at this problem right here. If I wanted to graph that, couldn't I first factor that expression? Now notice it's a difference of 2 squareds, right? X squared, 25 is 5 squared. So if you remember the pattern that we used here, well, wouldn't it just simply be x times x for x squared? Wouldn't it be 5 times 5 for the 25? And finally, we're going to make 1 a plus and 1 a minus. That's right. Now let's use a zero property. Okay? And that means this has to make a 0, which would mean negative 5 plus 5 is 0. And what number in there minus 5 would make a 0? Well, that'd be positive 5. So here are my 2 roots, or zeros again. Okay, guys? So here's basically how the graph is done. I know I have a root at negative 5. I have a root at positive 5. The thing I'm missing in this quadratic is, of course, the vertex. And there's no room here, guys. But the key thing is, remember that any x squared function, any even function, the left extreme is going to go up, just like the right extreme is going to go straight up on any even function. Now the middle, you could see, is pretty logical. It's going to come down like this and back up like that. Okay? Now this value down here, you'll eventually learn, if you don't know, is going to be the vertex at 0, negative 25. Okay? Again, I know that if I just put the 0 in. But the key idea is, you have a rough idea what a quadratic looks like, okay? And know that the left and right extremes will go up when it's a positive x squared, okay? If you don't understand what I'm talking about, you may want to watch my previous video on that, okay? But again, maybe we'll discuss it here in a moment as well. As a matter of fact, it wouldn't help to or hurt to discuss it right now, right? So let me skip ahead here, or skip back. And I thought I had the pictures in here, but I don't. Doggone it. So, anyways, let me pause the video myself, and I want to add something to this video. Okay, guys, hopefully I didn't screw up my video. I guess only time will tell. But what I want to do is something I think is very important. Okay? What I did was I went on Desmos and did a few little simple simulations here. Now notice over here I have all even functions, right? See how all the powers are even? And I want you to look over here and notice the red is a typical parabola, right? That's the x squared that I had graphed there, right? But again, I just want to show you without just telling you that notice the second function in blue right here. Look at the graph. Doesn't it look similar to a parabola, except it's a little more square at the bottom, near the vertex, right? Well, in other words, any even function will have that same shape. And in other words, the only thing with any even function you have to try to understand is that's what we mean by the left and the right sides of it always going up on a positive even function. Okay? On the contrary, notice what happens when they're negative. we have exactly the same curves, except now they're upside down. See how they're going down? But with a negative even function, the left and right sides will always go down. Okay, and hopefully you understand that. Now what about an odd function? Notice here, guys, I have odd functions, right? I have an x to the 3, x to the 5, x to the 7. If you look over there, they all make that same kind of snaky looking shape, don't they? See, what will stand out more? All right, but as you can see, they all have a similar shape. The higher the power, the more kind of square it gets near the center inflection point, as we like to call it, okay? But all odd functions have that same snaky or wavy shape. Whereas, if, notice this one, they're negative odd functions, they'll have the same shape, they'll just go the other way. So you basically, if you understand that, guys, then it's going to make your graphing a lot easier to understand. Okay? Now, this video is getting a little long, but I do want to do just one more problem real quick here, if you don't mind. This one right here, I know I can recognize as a special product. The 4x squared is 2x, right, squared. The 1 is a 1 squared. Because there's a minus 4x, isn't that really negative 2x doubled? You see? So this right here, guys, using the pattern of the special product that I showed you right here on the bottom of the screen, is my factored form. So again, using the 0 property, I know 2x minus 1 equals 0 somehow. And therefore I know 2x equals 1 when I add 1 to both sides. X therefore is 1/2 plus or minus, or sorry, it's actually a double root, isn't it? There's no plus or minus, it's a positive 1/2. So what's cool about this one, guys, is I'm just going to go to positive 1/2, somewhere about right there between the 0 and 1 in the middle is positive 1/2. Does everybody agree it makes a 0? But this is, because of the square, it's really a double root, okay? A double root means the vertex. Let me write that a little bit neater there. Kind of rushing here a little bit. And a double root means that's where the vertex is, okay, guys? And because it's a positive 4x squared, I know it's going to go up on the left and right side like any positive even function is going to do, okay? Remember what I showed you right here? Any positive even function, they always go up on the right and left side, right? All right? And so that's a rough sketch of what that function is going to look like. So guys, I think I may have to stop it there. It's getting a little long. So I hope this video helps you. Okay? And if I have time tomorrow, I'll make another video on this. But until then, bye.